hydraulic calculations and hydraulic calculation softwares. We will take abbreviation about the hydraulic calculation method as we talking in the first lectures, and after that we will using Elite software and PipeNet software for running the hydraulic calculation. Anyone have any question about the last lecture?
Mr. Ahmed, actually, the last lecture I was checking upload yesterday, but you did not upload.
Yes, I sent it 2 days ago to the admin of the site. He will prepare it and upload it. I think maximum tomorrow or 2 days.
Okay, so inshallah, once I will watch and then I want to discuss with you something, but now not possible.
Okay, okay. We will start today about hydraulic calculation. We will talking about hydraulic calculation steps. We already talking about these steps before, but this is a summary of hydraulic calculation steps. The first thing we start with occupancy hazard classification, and after that we will go to the determination of the number of system zone control valve. After that, for dry system only, we need to calculate the air supply specification for dry and pre-action systems only. In wet system, this step will not be important. Number 4, determine the design area. To calculate any water demand for sprinkler system, we need to specify the occupancy hazard classification. From the occupancy hazard classification, we can make a determination of design area and also determination of discharge density, so we can calculate the sprinkler flow rate. After that, we will add the hose stream allowance, and this be the total of steps number 6 and number 7 will be the pump flow rate. And using hydraulic calculation softwares, we will calculate the pump head, and by knowing the discharge time depending on the occupancy hazard classification, we can calculate tank size. First step, occupancy hazard classification. We already know that we have 3 hazard classification: light hazard, ordinary hazard, and extra hazard. Ordinary hazard divided to ordinary hazard group 1 and ordinary hazard group 2. Extra hazard already divided to extra hazard group 1 and extra hazard group 2. Number of zone control station, we already talking about that we have for light hazard, the maximum area per one zone control station is 4,831. The same for ordinary hazard, and for extra hazard and storage, the maximum area per zone control station will be 3,760. For example, if we have a project ordinary hazard have a floor area of 6,000 square meter, we can calculate the number of wet system zone control station by divide 6,000 by this number. We will get that the number of zone control station will be 2. The same for the pre-action system. But for the deluge or dry system, for the dry system, the number of zone control station will depending on transient calculation and the priming time calculation. We need to calculate the delivery time from the dry valve to the farthest sprinkler to be sure that the size of the system is suitable. This number is 30 second for spray cooling system, for example. So we need to make a priming time calculation using PipeNet software to determine the number of zone control stations for dry system. This step only for the dry system and pre-action system, calculating the air supply specification. Already we start to calculate the system volume. From this table, each pipe diameter give us the volume of this pipe diameter per meter. So depending on the size of our network, we can calculate the system volume of our network. After that, we will determine the air pressure requirement. This table give us the requirement of the air pressure for the dry system and pre-action system. If we have air maintenance device for system with tank mounted compressor, if we have a compressor, air maintenance device plus 30 psi to 2.1 bar. If we have our system is from 100 psi to 200 psi, then the compressor pressure will be plus 40 psi. And if we have the system already have the pressure, system pressure from 200 to 250 psi, the compressor pressure will be plus 50 psi for this number. The same for low air pressure supervisor switch and low air pressure switch zones. We can calculate the compressor flow or nitrogen cylinder flow needed for dry system from these equations. Compressor size CFM, cubic feet per minute, equal V is the volume of our network, B required air pressure from the last table from here, required air pressure, divided by 7.48 is constant number, multiplying by 14.7 constant number, and the T is the filling time, and we can take it 30 minutes. This is also a constant number. By knowing the volume of the network and the air required air pressure, we can calculate the compressor size. If we will use nitrogen cylinders instead of compressor flow, this equation for nitrogen cylinder, volume of cylinder equal the volume of the system multiplying by the required nitrogen pressure divided by 100. This equation for nitrogen cylinder and this equation for compressor flow. This step only in the dry system or pre-action system. After that, we can determine the design area by knowing the hazard occupancy classification. For wet system, the light hazard wet pipe system 1500, light hazard dry pipe system. For dry system and pre-action system, we already talking that we increase the design area by 30%. So light hazard dry pipe system will be 1950. For ordinary wet and dry, the same as light. For extra hazard wet system, 2500. For extra hazard dry system, increasing the number of wet system by 30% will be 3250. This is the design area of any sprinkler system. We use it to calculate the water demand of a sprinkler system. For deluge system, the design area is the entire protected area. All area protected by a deluge system will be the design area. We can run two calculations to calculate the pressure and the flow. We run calculation for most remote area to determine the maximum head or maximum pressure, and we calculate the most high hazard area to calculate the maximum flow rate.